Hi, I'm Jim and this is J&R Woodworking. Yesterday I did a video, or I should say I filmed a video, and we had a guest speaker. And through the excitement of finally getting together after a month, trying to get our schedules figured out, I forgot to introduce him. His name is Tim. I've known him and worked with him for well over 30 years, and he's the boss at the shop. I've rebuilt his snapper online through videos. I've rebuilt his snowblower, and I've done some other little things. But I just wanted to introduce him so you know who this guy is that's working in J&R Woodworking instead of me. I tried to stay out of the camera, and I tried to focus in on points that were important that he was pointing out. So if you're a woodworker, or if you want to be one or thinking about being one, this is a good video to watch because it really shows you how versatile this Leigh dovetail jig is. So if you're thinking about buying a dovetail jig, please check one of these out first before you buy one that you don't really like. So on to the video. Hi, I'm Jim and this is J&R Woodworking, and today, as promised, I'm going to show you a joint we did with the Leigh jig, and it's called a hopper joint. And this is a table that Tim made using this joint. And we're going to try to explain it to you because it's pretty complicated. Actually, Tim is going to explain this to you because it's pretty complicated. Now, this is the setups we had to go through to get to this point on that table.
So what makes this hopper joint a little more interesting than your typical joint is that the boards are splayed at 10 degrees. And the intersection, therefore, is 90 degrees when you look straight down on top of it. However, when you look along the joint line where the boards intersect, it's something other than 90 degrees. If you use a square, you can see that's 90 degrees. Where the boards meet, you can see a little bit of a gap. So it's that other than 90 degrees that we want to concern ourselves with. And when I looked at this, I decided I'd like to do a dovetail joint. And I went online and looked for some resource material, and I found that there were antique originals that all had hand-carved dovetail joints. However, I could not find any resources that showed videos on how to make a dovetail joint that was produced with any kind of a fixture or a jig or a router. The only source I found was a technical manual produced by Leigh Corporation, and they manufacture a line of dovetailing jigs, and Jim happens to have one of those, so he was kind enough to let me borrow that in exchange for describing my experience with making this joint. So that's what I'm going to try to do today for everybody. I would suggest that this technical document is the Bible to go by. There is all the information in here that you need to make this joint. Well, what I would like to add are just some of the things that I can point out that are pitfalls in some areas that might cause you some distress, or things that will make your project not turn out the way you want them to. So let's get started. First of all, let me get the notes I had. From the start, the very first thing I found was most useful was to have boards that were flat and straight. The way these joints interlock, if you're not starting out with material that's flat and straight, you're going to have problems because the joints will not fit properly. So flat and straight is the most important thing. The practice pieces I started with, I made from poplar. This table I made is my practice table. That's also made from poplar. The wood I purchased from Menards. It's surfaced or sanded 4 sides, and I kind of picked through what they had there, and the wood worked out very well for me. I didn't have any problems with that, so I was happy with that. So first and foremost, that's what you want to start out with. How am I doing so far?
Oh, sounds good.
So far, so good. All right. To start the project, you'll need to size your boards for length. Just rough cut them to length. The next thing you'll want to do is machine some bevels on the edges with your table saw. Now, since the sides of the table are splayed out at 10 degrees, the top edges are going to also have to have that 10 degrees in order that they are parallel with the floor. So I just set the blade on my table saw at 10 degrees, set up a fence, and ran the boards through, two of them, so they were both identical widths. Once I had that done, I was left with two boards that I had to determine which were going to be the tail board and which one was going to be the pin board, because on a dovetail you need one of each. The pin board slides into the tail board. At this point, when you have the bevels on, I set it on the table. The bevel is flush with the table bottom. The top is tipping towards the left. In that position, I know the inside here, which is the right side, is going to be the inside of the table. Okay, just like this. This is the inside table. That's another important bullet point to remember, is identify and always know which side is the inside, because that becomes very important as you proceed and orient the parts to manufacture them. So at this point, once I've determined what that is, I write inside, and I write that on both the boards I'm using. You also need to determine which one is your tail board and which is your pin board. That's up to you what you want to write on there. It's important to know which one is which. Once you have determined that, you'll have to mark. You'll take your board and say, this is our tail board and this is our pin board. You'll put the pin board next to the tail board, resting on the table, and draw a pencil line on the inside of the pin board. Then you'll do the same thing with the tail board. You'll draw a pencil line on the inside of the tail board. That represents the thickness of the mating board. You'll use that when you set up your router, so it's important to have a nice, accurate, straight line. Once you've done that, oh, I made a mistake.
What's that?
I forgot. We can't write that on there until we machine our 10 degrees on there.
Oh, okay.
So we're going to have to go back. We're going to have to backtrack a little bit before we put our lines on there. So we've got our boards flat. We've got 10 degrees on the top and the bottom. Now we have to put this angle on the side. I'm sorry about this. To do that, we set our table saw up and we tip our miter at our desired 10 degree angle. And now we have to set the blade at a certain angle. So what is that certain blade angle? We know it's not 90 degrees, because with our square we notice that when we look down that edge it's something other than 90 degrees. What is that angle? Well, we can easily refer to this Leigh technical document, and they have a nice little table that shows us that if we want a side slope of 10 degrees, we need to set our blade at 1.5 degrees.
Let me see that. This is the chart he's talking about. And you can download these and get your own copy.
Yeah, I would suggest downloading that and even looking at that while you're looking at the video.
Yeah,
that
will
will probably help. So we've got our miter gauge. I tipped it at 10 degrees. Saw blades tip this way at 1 degrees, and we run our part through. Same thing with the tail board. We'll tip this one 10 degrees and 1.5 degrees. Now, another important note is if you've got a table saw like mine, where the table is flat, the saw blade tips to the left 1.5 degrees. It's important when you're making these cuts, always have the inside face down on the table. Doesn't matter which end of the board you're cutting or whether you're cutting the tail board or the pin board, always have the inside face down. So by doing that, you'll know, okay, if you get it mixed up, how do I tell which has the 1.5 degrees on it? Well, you could use a protractor, or if you look to see which is the longest face is always going to be the inside face. And so you can keep track of it that way too if you get mixed up. Longest face is always inside face, and that way you should avoid some problems. So the point we're at now is we've got boards that look very similar to this, 10 degrees on each end, 10-degree bevel here, 1.5 degrees this way, and we're ready to do the marking, which I had gotten ahead of myself on before. So you put the pin board up next to the tail board and do the same thing for the tail board against the pin board, marking the depth on the inside. There again, it's important to note the inside of the board, so your depth is marked with a pencil line on the inside. Okay, now your blade should still be set up at 1.5 degrees. On the tail board only, you have to machine a 1.5 degree angle. Okay, so to do that, set your fence up, move it over close to the blade, run your tail board through vertically until that 1.5 degrees just comes up to the depth marking you have on the inside face of the tail board. What that gives you when you're done is a 90-degree angle from the edge to the inside face of the tail board. Like that. Okay, that's important to note, but you only do this to the tail board. What will happen is you will make your pin board and it will fit up right against that surface that you've machined, and then everything will come out the way it's supposed to. So after having done that, you're done with the table saw and you can move on to the router.
Now,
So,
at what point did you make your fixture?
this fixture,
Yeah.
before I even started.
Okay.
So there's some background that you want to do before you attempt this project. In fact, the Leigh technical document starts out with a little warning sign. They say these instructions are based on the assumption you're fully conversant with the dovetailing instructions in the Leigh jig user guide. Do not attempt the following procedures until you are. Well, Jim brought this over and dropped it off, and I had never made a dovetail in my life. But I think I spent a good Saturday playing around with this, and by the end of the day I had made this variety of shapes. But I started by looking at the manual that came with the unit, and I started by making a standard dovetail box. And this is the very first one I made, and as you can see, everything came out nicely. The fit is very nice, both the way the dovetail meets with the pin, and the top and bottom surfaces of both parts are lined up. One reason that is because this is a very accurate jig, and it has some very nice stops. So if you're doing a box like this, you are able to utilize those stops, and you will get very good repeatability and be very happy with this with minimal use. It's a very, very nice unit. It becomes a little more challenging with these angled dovetails because you're not able to use the stops. In fact, the accuracy comes down to how well you can draw a pencil line. And that's something that you can do. You just have to be careful with it. So you just have to take your time and not get mixed up on what you're doing, and you should be able to do it. But there are some things you have to do ahead of time, Joe. You have to be familiar with how the unit works. And then in preparation for making this type of joint, in this manual, they describe the process to make this little fixture. And this fixture will hold the tailboard at 1.5 degrees. Now that 1.5 degrees probably sounds familiar because that's what we set our table saw blade at. And we put that 1.5 degrees on the inside face of the tailboard. Well, we're going to have to do some more routing on that tailboard at 1.5 degrees, so we have to make this fixture. And I don't think I'll go into exactly how to make it because it's very detailed in the technical document, right, Jim?
Yeah, if I can find it here, I'll show you a picture of it.
But it's a very simple thing to make. This one was made out of maple, so you can reuse it. Nothing too difficult at all.
Here it shows using it with your board in place. And somewhere in here it shows how to make it. Oh yeah, here's the instructions here, how to make the fixture.
So before we get into the router, let me just recap what I did here. What I found as important things. Follow the Leigh manual, but I'm just pointing out, start with straight flat boards. Mark the inside on every piece so you know what that is. On your table saw, the inside face of each side is always down. The longest face is always the inside face. And that 1.5 degree angle that you put on the inside is only on the tailboard. So those are several points that I struggled to thoroughly understand in my mind when I was going through this documentation, but that might help you if you just realize those are things you have to watch out for. As far as the router fixture goes, there are videos out there on how to set up the router bit for standard dovetail joints. The manual is a very good manual on how to do it too. I mostly just follow the manual on that. And the first thing you do is do a box joint like we talked about. And the important thing here in doing this is you'll have to set up the correct dimension for your pins, because you can adjust the pin setting. You can make your pins wider or you can make them narrower, and by adjusting that it affects how well the joint fits together. Now when you do a box type joint like this, you do the tails first and then you do the pins. By doing the pins last, you can always adjust them. If the fit's too tight, you can make an adjustment and you can run them through again, and your pins will be a little looser and you've got room for the glue and things will slide together nicely. Unfortunately, because of the way you have to put together this angle dovetail joint, you have to do the pins first and then the tails. The reason that you have to do that is because we're not using fixed stops. We're using pencil lines drawn on the ends of boards. If we tried to do the tails first, there would be no material where we want to write our pencil line in order to line up on the pins. So we have to do the pins first. So it's important to have the pins adjusted to the correct size before you move in, because there's really no adjustment for fit once you get going along. Okay, so not for fit, you can adjust for height and depth, for your depth of cut. But as far as how it fits together,
So,
you're locked into that.
so basically you're going to be doing a couple of these as practice pieces to get your settings that you want.
I made quite a few practice pieces, and it's I mean, that's why I do this. Is practicing. You do this to learn, figure out how to do it, and if you make a mistake, it's easy. You cut off these pins and you start all over again, and kind of learn as you go. That's why you do practice pieces. This old table right here is my practice table. So moving on. So we've got everything marked out. We know which is the all-important inside. We don't use a stop with our hopper joint. All alignments controlled with our pencil lines. So we've got our pin board, And we're going to do our pin board first. And we want to be able to set our depth of cut with the router bit. So we've got to be able to see our line. So in order to set our depth and see our line, that line has to face us. So we'll slip our board up into the fixture, clamp her in place, and this of course is all fully adjustable. And the nice thing about this Leigh jig is that the dovetail spacing is fully adjustable. You can make these virtually any size you want. And what they suggest is you adjust these things and by eye. It doesn't have to be specifically any one dimension, just make sure they look good. They suggest the half pins on the end not be any narrower than the full pins in the center part of the board. They don't want to get too skinny. I also made them plenty wide just in case I needed extra material on the end, in case I didn't have a good match with mating parts, and I could always run it through a saw or sand it down. So I made these plenty thick on the outside edges here, as you can see. All right, to set your depth on the pins, you use a straight bit. I don't know if you can see that, just a straight bit. And these are all Leigh bits, right? These Jim came from Leigh. And you can read all about how they suggest you set it, put it in there. But to set the depth of cut, you adjust your router so the bottom of your bit is basically splitting the pencil line that you have scribed, which represents the back surface of the mating board. Now, what happens if you go beyond the line?
Which one of these you want?
That's the one that's lower. So you can say to yourself, well, what if I go beyond the line? I'll just end up with a situation like this, where I've got more material there that I can just sand off. Well, that's fine. You've got a lot of sanding to do. One downside to that is that since these pins are at a 10-degree angle, when you assemble it, this board actually goes downhill. And if this becomes too deep, this top surface, as you can see, is below that surface. So that's what happens if you go too deep. Well, what happens if you don't go down all the way to your pencil line? Well, then you end up with a situation like this, if you can see that right here, where this surface is sub-flush to your outside surface. And as you can see, if you look close, it's not all the way down to the pencil line there. So those are two consequences of being either side of the pencil line. So best case is try to split the pencil line
as accurately as you can.
As you can. Well,
because not much below or above that pencil line is going to create that bad joint.
Yeah, the more, I'd use a really sharp pencil and be very careful and take your time. And you should be able to work it out. So you've got the board facing this way because you need the pencil line to set your depth of cut. However, when you make your pins, on your pin board, the inside face goes against your fixture. There again, important to remember what the inside face is. Inside face against the fixture. Put it in place. Now, one thing I do, I ran across this from experience. First time I did this, I'm routing, this board moved on me. So that got messed up. So what I've done since then is I've taken this wrench that comes with the Leigh jig, if you can see it, and I just mounted it. There's a little T-slide that comes with it. Mm-hmm. And I just push it over and tighten the screw just to prevent it from moving on me.
Plus it would help you line up your next piece.
Yeah, it'll help line up the next piece then too. So now you've got your part in. This was kind of all eyeballed. very important thing to do is take a pencil and make a mark, and I usually use the first full set of fingers that are in here, and I mark the center line, and it's very easy to see where those two meet, and I mark that line right on the board. And that's very important to be accurate with that, because that point then gets transferred to your tailboard and will line up and determine how the fit is going to be here, because we don't have a stop that we can use to transfer the location from our pin board to our tailboard. This is only going to stop from one pin board to the next. So I do that first thing. I get it in there, I mark it. You can use your router, and you have to be very careful as you go through and just follow the normal routing procedures and be very careful. I ran into some issues as I was making these things with some tear out on the back side of these. I found that originally I made one where I made a pass on the outside edge here, and it kind of tore out on the back side. Well, on later samples I found I had better luck by removing most of the material from the inner part and then going back and taking cleanup cuts. Trying for the most part as I can to have the cutter cut into the wood rather than try to split it out. Those are all woodworking techniques I think people can work on. But from here on, following the jig and the fixturing, you just follow what Leigh suggests and that should come out just fine. Once you're done with one side, if you were doing a box, you'd have a pin set up on the opposite side of this board. You would just flip it around, change your stop, and just repeat the same process, put a little pencil mark. But in this case, we've only got a single-ended one.
So you want to do all the boards with one end
Yep,
before you change your stop.
yep, so you do all the pins, and there again, make sure that you're always, you've got your inside face in a direction it's supposed to be. Because if you'll be flipping this thing around, you don't want to have it on the opposite side, or things just aren't going to match up. I've learned that from experience. This table's about an inch shorter because I think I got all the dovetails in and I was assembling it, and I found that I had one, I don't remember what the error was, but it was off one way or the other and it just wouldn't go together, so I ended up having to cut off the dovetails from one end and make it a little bit shorter. But that's how you learn, and that's why you do this stuff. So okay, we've got the pin board done. We'll move on. Do you have any other questions about that one so far?
No, I think that's...
All right.
Now the paper he's using right now is kind of filling in the blanks in this manual from Leigh, and just tells you what pitfalls you could fall into making this joint. So these would be available if you're interested.
Yeah, just clears up some of the pitfalls that you can make. So all the pins are in. Those are fixed. We can't move them. So now we have to put the tails in the correct position so that that repeats. So here's our pencil mark that we made, that we put in there. Let's see, we'll use this one. That we put in there before we did any machining. Here's our pencil line. Now we have to transfer that to our tailboard. Okay. So you can see on our tailboard here that if we tried to do it now, which this one is already machined, we've got our pins and tails, there's no material here to transfer that pencil line to. That's why on this type of joint we have to do the pin board first, because if we did the tailboard first, there would be no material to write a pencil line to register it back to the pin board. Okay?
And this is another crucial
So this is another crucial step. So say we'll go at the other end and we'll say we've already put our dovetail in there. And now we're trying to line things up. So this is our line that we transferred from the center line of the fingers. You transfer that little mark to the inside face of the tailboard, which would be right there. From that point, you make a horizontal line, one that's parallel with the top and the bottom here. And we're at 10 degrees, so I'd set my protractor at 10 degrees. Okay. It keeps moving on me.
You hold the board
Can you see it?
best I can.
You see it okay? So you draw that line in there, 10 degrees, to the outside face of the tailboard. Now, from the outside, so this point right here is actually where the outside point of the pin board is actually going to be once you remove all this material.
And it's assembled.
When it's assembled. When it's assembled. Now, in order to line this up with our fingerboard again, since we hold this in our assembly like this, we've got to run a line back perpendicular to our face. So we'll set this back at 90 degrees. Okay. And we transfer that point up to here. Okay. That's our line. So we'll take that line.
Let's see that second.
Want to see it?
And this is what it's going to look like when you get it all drawn on there. This is the perpendicular line, and that's what you're going to use to line up the next step with this fixture that you made.
All right. Do we want to stop it here or keep going while we put this in?
We're going to set this up. We'll be right back. Okay, before we go to the second half, I want to show you a book that he found online that's pretty interesting. You might want to try and find one yourself.
Well, and actually, I got put onto it by looking at this, once again, the Leigh manual. They refer to this chart that we looked at earlier, and they say they took that chart from this wood joiner's handbook. Well, went online and found the wood joiner's handbook. And if you really want to get into the technical aspects of what to do with these kind of joints, there's tables in here, there's formulas in here, because as you work with different angles, well, that 1.5 degrees that we figured that we wanted to use is going to be something other than 1.5 degrees. So you can either go by a chart, or you can, if you're into math, you can figure all those numbers out to yourself. So, and the book itself has a wealth of other joints to make too.
Here's Tim's math on
I
figuring
don't know
it
if
out.
that's right. I wouldn't.
I think it'd be a lot easier for most of us to just get a hold of one of these books. And it shows different ways to make this hopper joint in this book. It shows the dovetail, like he did. It shows just a mitered corner and a butt joint on the corner. And I believe you've got one of these tables at home that you had since you were a kid.
Yeah.
And them corners are what?
There's a butt joint.
Butt joints
Yeah.
on them with screws going
Yeah,
through, and I
little buttons.
had buttons hiding the
Yeah.
screws. So there's several different ways you can make this joint. But this is a handy handbook to have. And again, he found it on Amazon?
Yeah, I think that came from Amazon. Yeah.
Amazon.
But it's referred to in that the Leigh manual here.
So
Good
we
resource.
just thought we'd throw that in the middle of this whole mess. And you can see if you can find one of these to help you out on all types of joints. It's not just dovetails. All right.
And we're back. Okay. So what we did is install this little fixture that Leigh describes how to make. It just takes a little bit because you've got a lot of unscrewing here to do to get it to fit it in. Where we left off is we've scribed our line, and we're going to put that in the fixture and line this mark up with the center of that same finger that we use to mark the line on the pin board. So you kind of go like that. And I've got the pin part of the finger sticking out here, so it's easier for me to line that up. You'll note that this board is not held vertically. This fixture holds the board in here at a 1.5 degree angle. Okay, so now when you've done that, you take your fingerboard off, flip it around, and line it up. And since this fixture pushes this board out farther than it normally would, I line it up on as far back as you can see the register marks on the scale. You want it to be parallel. That way you come out when you set up your router.
So every time you put another one of these boards in, you got to flip this back over to line up your line.
Yep.
Because you can't use this stop.
And there again, on the to set your depth, just bring your router in, set it to split the line. And then on the pin board, or the tail pieces, it's just the opposite. So our inside face, tail inside face, is facing you when you do these pin boards. So you could, let's see, I think, can you line it up like this? Yeah, you could also line it up like that if you wanted to.
Oh, okay, just bring it, yeah. So you wouldn't have to
So
flip
that
this
won't have
every
to flip.
time.
You can just line it up like
You
that.
can line it up. I can't see if I'm in the right place here. I can't see the screen.
Anyway.
You can look right down here and line that line up with the crack on this, between these two fingers.
And your inside face is out. And from there on, it's pretty much the same procedure as the pins, just using your dovetail router and being careful not to have breakout. That was the only real issue I had with the routers was breakout. And it probably varies depending on what kind of wood you're using too.
Yeah. No, you didn't have any trouble with it chipping with the maple, did
The
you?
maple, I didn't seem to have as big of an issue with maple. So,
Harder wood than.
yeah. So this was my practice one, the real one I made out of maple. Is that clear as mud or?
Yeah. Well, I would definitely have to do some practicing to get a table to come out like this
Well,
one did.
You got to get your mind wrapped around. So I did this about a month ago, and Jim asked me to come over today to shoot a little video on it. So I spent last evening going over the notes and trying to remember how to do it, and it took a while just to refresh my own memory, having done it myself. So it's one of those things, the more you do it, the more familiar you'll be with it. But if you follow the Leigh manual, you'll be just fine. And if you listen to anything I said, I'm just pointing out some of the pitfalls. And you probably will make some mistakes, but we all do. And that's how you learn. That's what makes it interesting and fun.
Yeah. Now, I don't know if we mentioned this was originally called a dough box.
Dough box table.
They actually used these, I don't know how long ago, to, they used the top of it, I guess, to get the dough ready and then knead it. And then they opened it up and put the dough inside and let it raise. So that actually was a function for this style of a table. I imagine it was probably taller so you could use it in a kitchen, and how it became a table to put in your living room next to your couch. I guess they just liked the looks of it and decided to make furniture out of it.
Well, yeah, even this one, originally, when I first saw a table like this, it looked more colonial. It had turned legs and it had kind of a scalloped skirt. I decided to make it a little bit different, more like a Norm table maybe.
Yeah, I personally like the tapered legs better than the colonial round ones. I think it just better looking to me.
But no, it's a very interesting experience. I appreciate Jim letting me use this guy, so I couldn't have done it without that.
And
very interesting.
When we did it, or when he did it, we also had this. This is the support that Leigh sells with the dust pickup. And believe me, these things will make a huge mess without this attachment.
So here's another mistake that I made, that if you buy one of these so you don't have the same issue. When we put this together, now Jim bought this, he never played with it at all, so he brought it over to my house. I was the one that put this all on here. You follow directions, this is pretty much centered on this plastic part, and of course I'm being very careful, and I put the router in here, I'm doing test cuts and everything, all that works great. And so I think, okay, I'm good to go. Well, the very first cuts I do are with a similar joint like this, where I'm all the way over to one side, and what happened is you drop this router on, and if these wires were over central the way they were, when I dropped this router down on top of it, inadvertently I was all the way over to the side here, this stopped. I ended up being on top of one of these wires because this only went over so far. And what happened was this was kind of binding up and acting strange on me, so when I lifted it up, I clipped one of the corners of his fingers, so I bought him some new ones of those.
So if you look directly at this thing, again, I can't see the screen, you'll notice that the wires are not centered in this plastic block. There's several holes in here, and you can snap them wires in wherever you want, and basically that is to spread these out or put them together to fit the base of your router. You just don't want to have them so when you're all the way over here you're bound up. I did notice some guys that use these, they had them spread out so they were, say this is the router base, they had them way out here, so they didn't have that problem of binding.
But this, yeah, so when you do lift up your router, make sure you're back far enough so when you come up, that doesn't happen. But this thing worked great, the vacuum pickup, that made a big difference.
Oh, I'm gonna have to make some boxes now, I guess.
That's the way you figure it out. But no, I had fun with it. Learned a lot. On to other things now.
Yeah.
All right.
Well, I hope you enjoyed this with our, I don't know what to, expert joint maker. We thought a little bit about going over to his shop and showing all this, but he said his shop's like mine's really messy. So we thought we'd come over here. At least this end of the room is cleaned up and I have room to do stuff. But guest speaker, I guess that's the word I was looking for.
Better than expert, definitely not. Learner. It's always interesting to learn how to do new things.
Yeah. So I guess that's it. If you have any questions or comments, put them in the little box below or send me an email, and I'm sure I'll get a hold of Tim to answer your questions. So until next time, work safe, have fun, and we'll talk to you soon. So long.